everyone, welcome back to our channel. In this video and in the upcoming videos we will be discussing Karnataka's HSTR chemistry topics, and we will also discuss about the type of questions which are asked in the Karnataka HSTR. So let's start with carbon and its compounds. So by looking at this word, means carbon and its compounds, what is basically carbon? Where does this name come from? So the name carbon originated from the Latin word carbo, which means charcoal. Okay, then what are its compounds? What are carbon compounds? Carbon compounds are those molecules contain a carbon atom. For example, consider this chloroform, that is CHCl3. It is a molecule. Here carbon is attached to one hydrogen and three chlorine atoms. So in this molecule a carbon is present, so it is a carbon atom. Another example we can take, it is carbon dioxide. Here two oxygen atoms are attached to carbon, so it is also a carbon compound. So now let us study some basic concepts of this carbon. So we all know that atomic number of carbon is 6. That is, atomic number of carbon is 6. Then what is its electronic configuration? So electronic configuration of carbon is 1s2, 2s2 and 2p2. So now let's see how this is arranged. So let's consider it as a carbon. Here is the nucleus present, and it is the first shell, and it is second shell. We all know that the first shell is K, and the value of K is 1, and the second shell is L, and the value of L is 2. So we have the formula 2n square to show how the electrons are filled in the shells. So when the value of n is 1, that is in the K shell, let's see, it is in the place of n we will put 1 square, so it is 2. So the number of electrons which can fit in the K shell is 2. So I'll write here 1s2. So 2 electrons can be fitted in the K shell. So now let's study how much electrons can be fitted in the L shell. We know this 2n square formula, and 2 into this one is n is 2, we will get 8. The number of electrons which can be filled in the L shell is 8 electrons. We have 4 electrons here, so these 4 electrons can be fitted here. So we can say that the number of valence electrons, means the outermost electrons, are 4 in the carbon. And remember that this carbon is a 14th group element, and it is a non-metal. Now let's study the uses of carbon in our daily life. There are immense uses of carbon in our daily life. We can see some of the important uses of carbon. So 18% of the human body is made up of carbon itself. The food we intake, that is, we take the food in the form of carbohydrates, sugars, proteins, are all are carbon compounds. That is, carbohydrates, sugars, proteins, these are all carbon compounds. So we use fuels like oil, coal, natural gas, which are hydrocarbons extracted from the fossil fuels. These are all made up of carbon. So then oil, coal, natural gas, these are all made up of carbon atoms. So in the polymers, paints, fibers, solvents, plastics, everywhere carbon is present. In the petrochemical industries, that is polymers industries, paints, fibers, solvents, and plastics. These are all made up of carbon. So carbon is also present in different allotropic forms. So carbon is present in different forms. One of the form is diamond. We all know the use of diamond. Here comes the important topic. So that is carbon dating. So why this carbon dating is done is that it is to measure the age of things by the scientist. Like age of fossils can be determined by the carbon dating. So let's see the important question asked here. I said that by doing carbon dating we can measure the age of things, that is like fossils. So here the question may be asked like this: which is the carbon form used to measure the age of fossils? I have said that carbon will be used to measure the age of fossils, but which form of carbon? So carbon is present in the form of different isotopes. So the carbon 14 is the right answer for this. Carbon 14 is a rare form used to measure the age of fossils, bones and other things. And this is very important. And remember that earth crust has only 0.02% of carbon and the atmosphere has 0.03% of carbon dioxide. Let's discuss another important topic, that is bonding in carbon, whether it is ionic bond or covalent bond. Now let's discuss some basic points of ionic bond and covalent bond. Now here in the ionic bond, here by seeing this name only we can tell that ions are formed, that is ionic bond. So let's study the cation Na plus and take an example for anion, that is Cl minus. It is cation and it is anion. When both of these combine, then we will get NaCl. So let's study how it is formed. And here comes the important point. So the reactivity of every element is based on the tendency to attain a completely filled outer shell, that is noble gas configuration it should attain, that is helium, neon configuration, etc. So for helium we know that it has 2 electronic configuration. For the neon it is having 8 electronic configuration. So every element is willing to complete its outer shell, that is it should have 2 or 8 electrons, or noble gas configuration must be present. So look here, in the Na, that is in the sodium, the electronic configuration is 1s2, 2s2, 2p6 and 3s1. So here are 2 electrons. This is the first shell, that is K shell, and these are 8 electrons. So it is the second shell, that is L, and in the third shell, that is M, only 1 electron is present. That is why I represented 1 electron in the outer shell. So in the first K shell 2 electrons are present, in the second L shell 8 electrons are present, and in the final outer shell only 1 electron is present. If this electron leaves, then the outer shell will contain 8 electrons, then also it will attain noble gas configuration. So here in the chlorine we can see the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So in the K shell, that is in the first shell only 2 electrons can be possible, and in the second L shell 8 electrons can be possible, and in the third M shell you can calculate, it will get 18 electrons can be filled. So here 1, 2, 3, 4, 5, 6, 7 electrons, that is 3s2 and 3p5 electrons are filled in the outer shell. So the number of electrons in the outer shell in the chlorine is 1, 2, 3, 4, 5, 6, 7. So it needs another 1 electron to fill its outer shell or to attain noble gas configuration. Then how it is possible? So if the Na gives one of its outer electron to the Cl, then its outer electronic configuration, that is outer shell, will contain 8 electrons. Then it will be having noble gas configuration. If the Cl gets one of the electron from the Na, then it will get 8 electrons in the outer shell, then it will also attain noble gas configuration. So this electron is moved towards here, so the electron is filled here. So 1, 2, 3, 4, 5, 6, 7, 8 electrons, then the Cl is attaining noble gas configuration. As you can see, this Na is also having noble gas configuration. Why? Because it has given one of its electron to the Cl. Now, looking at this example, we can tell that ionic bond is a chemical bond formed when one atom gives one or more electron to the other atom. Here this Cl is not giving anything to the sodium, but this Na is giving one electron to the Cl. Here mutual sharing is not present, only one atom will share its electron to the other atom. So now the Na has given one electron, so it will get Na plus charge, and the Cl is getting one electron and it is getting Cl minus charge. This is about the ionic bonding. So we need to know whether carbon is an ionic bond or covalent bond. Now let's study about the covalent bonding. So let's see covalent bonding in water molecule, that is H2O molecule. We know that hydrogen consists of only one electron, that too in the K shell, and here is an hydrogen, that is H2O. Here is one hydrogen and other hydrogen is present here. Electron of this hydrogen is here, electron of this hydrogen is here. And we know that oxygen is having 8 electrons. So in the first shell 2 electrons are filled, in the outermost shell 6 electrons are filled. So this hydrogen requires another 1 electron to attain noble gas configuration. That means it needs 2. Means to attain helium gas configuration. And this hydrogen also requires another electron to attain noble gas configuration. Here in the outer shell of the oxygen 6 electrons are present and it requires another 2 electrons to attain noble gas configuration. So now in this case only mutual sharing of electrons takes place. Look here carefully. When this electron and this electron forms a bond, and when this electron and when this electron forms a bond, we can see that hydrogen has attained its noble configuration and this hydrogen has attained its noble configuration, that is 1, 2 and here also 1, 2. So here you can see this electron and this electron I have mentioned here, and this electron and this electron I have mentioned here, and another 4 electrons of the oxygen is present here. So here for the oxygen is having 1, 2, 3, 4, 5, 6, 7, 8 electrons. So oxygen also attained noble gas configuration. So instead of losing one or more electron from a single atom, there will be mutual sharing of electrons. Oxygen is sharing one of the electron with the hydrogen, both this hydrogen and this hydrogen. So these hydrogens are also sharing electrons with the oxygen. So the mutual sharing of electrons takes place in the covalent bonding. So now I will discuss another one important topic. Now we know that HCl molecule. By seeing this we will think that it is having an ionic bond. Why? Because we think H plus and Cl minus ions it forms, so it become ionic bond. But this is not true. The bonding in HCl is covalent bonding. But whenever it is present in the form of aqueous form, then it will get ionic bonding. That means when the HCl is in the water, it forms HCl acid, which consists of H plus and Cl minus ions. Basically, HCl is having covalent bonding. This type of questions can also be asked. Like, what is the type of bonding in HCl? We should say that it is having a covalent bond. But whenever it is in the aqueous form, it will get ionic bond. So hydrogen is having 1 electron in the outer shell, and this Cl is having 7 electrons in the outer shell. So H, when it gets one of the electron from the Cl, it attains noble gas configuration. So in order to get the 8 electrons in Cl, it has to share one of the electron with the hydrogen. Then it will get 8 electrons. See here, in the outermost shell it is consisting of 7 electrons. If it's share one of the electron of hydrogen, then it will become 8 electrons. In the outermost electron, in the hydrogen is having a single electron. If it shares one of the electron with the Cl, then it will get 2 electrons. So both of the hydrogen and Cl will get noble gas configuration. So now comes the important topic here. Now we should study the bonding in carbon. Whatever I explained above is the basics about ionic bonding and covalent bonding. Now let's see the bonding in carbon, whether it is ionic or covalent bond. So here is a carbon, first shell and second shell. In the first K shell we are having 2 electrons, and in the second we are having 4 electrons. So now let's see if the ionic bonding is possible in carbon or not. So we know that here are 4 electrons in the outermost shell. So in order to become a ionic bonding, it should share its 4 electrons to the another atom. So the outermost will become 2, then it will get noble gas configuration. Or either it should gain 4 electrons. If it gains 4 electrons, then the outermost shell will have 8 electrons, then also it will attain noble gas configuration. So that is by gaining 4 electrons or losing 4 electrons, it can achieve noble gas configuration. So, but this is not possible. I will explain you why this is not possible also. So, consider, for example, if it gains 4 electrons from another atom. So, I will write this 4 electrons here. So, now it has attained 8 electrons in the outermost shell. So, if it gains 4 electrons, then it will form a C4 minus anion. So, gaining means C4 minus anion. But we know that in the nucleus of a carbon, it is having 6 protons. It will be difficult for the nucleus with a 6 protons to hold on to 10 electrons. So, that is why this C4 minus anion is not possible. Why? Because in the nucleus it is having 6 protons. So if at all 4 electrons are added, then total number of electrons will be 10 electrons. So this nucleus with 6 protons cannot hold these 10 electrons. So that is, it has to hold 10 extra electrons. It is not possible. So this C4 minus anion is not possible. Next case is if it loses 4 electrons. Now in the first case we have seen if it gains 4 electrons. Now if it loses 4 electrons, what will happen? So here is the carbon and here is the 2 electrons, and in the outermost shell is 4 electrons. So if it loses 4 electrons outermost shell will have 2 electrons. Then also it can attain noble gas configuration. But this is also not possible. Why it is not possible means, if in case it loses its 4 electrons, then see here why it is not possible means, here the carbon is having a smaller size and the force of attraction between the nucleus and the electrons very high. It requires large amount of energy to remove the 4 electrons. So C4 plus cation is also not possible. Why? Because the force of attraction between the nucleus and the outer electrons is very high. Here in the nucleus we already know that it is having 6 protons. If at all the 4 electrons are removed, only 2 electrons will be remaining here. So it is not possible due to the force of attraction is very high. I have written in the point wise detailedly. See, first case, if it gains 4 electrons forming C4 minus anion, it would be difficult for the nucleus with 6 protons to hold on to the 10 electrons, that is extra 4 electrons. And another case is, so if at all it loses 4 electrons forming C4 plus cation, but it would require a large amount of energy to remove 4 electrons, leaving behind carbon cation with 6 protons in its nucleus, holding on to just 2 electrons. This is the reason why the carbon cannot form ionic bond. The bond formed in the carbon is covalent bonding, that is mutual sharing of electrons takes place in the carbon. Let's see some simple example of covalent bonding in the hydrogen atoms. See, H2. Let's consider H2. This is H and this is H. Outer electron means it is having a single electron. It is also having a single electron. So to attain noble gas configuration, this hydrogen requires another 1 electron. This hydrogen also requires another 1 electron. So if the mutual sharing of electrons is there, then this hydrogen has also got 2 electrons. This hydrogen has also got 2 electrons. Then it has attained noble gas configuration. This is about the covalent bonding. So now let us see the covalent bonding in the carbon compound. Let's see the covalent bonding in the ethane molecule. Here ethane means C2H6. It is a carbon compound. So here let's write the structure of ethane. Here is a carbon and here is a carbon. We came to know that carbon is tetravalent. That means it should have 4 bonds. So here is a carbon, here is a carbon, and these are the hydrogens. Now this hydrogen is having a single electron and this hydrogen is also having a single electron. This hydrogen is having a single electron. Like this, all the hydrogens are having a single electron. So here the carbon is having 4 electrons outside. This carbon is also having 4 electrons outside. Now if this hydrogen want to attain noble gas configuration, it has to share electron with the another electron. That is like this, and this hydrogen will share electron with this electron, and this hydrogen with this electron, this one with this, now all the hydrogens has achieved noble gas configuration. And what about these carbon atoms? If these carbon atoms are having 4 electrons outside, and to attain noble gas configuration, it has to gain another 4 electrons. That is 1 from hydrogen and 1 from this hydrogen, 1 from this hydrogen, and 1 from this carbon. See here, this total will become 1, 2, 3, 4, 5, 6, 7, 8 electrons. And same in this case also, has 8 electrons. So here is the mutual sharing of electrons takes place. And important points to remember that in the ionic bond, ions are formed, as I have already said to you. But in the covalent bonding, there is no formation of any ions. If the ions are formed, then it will be good conductor of electricity. So here the compounds, that is covalently bonded compounds, will not have any ions. So these are non-conductors of electricity. These are largely non-conductors of electricity. Why? Because no ions are present. And the force of attraction between the molecules are also not very strong. And the carbon is a non-metal, non-lustrous, non-malleable and non-ductile. Non-lustrous means it is not having shining, and non-malleable means it can't bend and twist. We cannot bend and twist into other shapes. And non-ductile means we can not make into a thin wire. This is the basic introduction about the carbon and its compounds chapter. In the upcoming videos, we'll discuss the topic one by one. Thank you for watching.